30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Good evening to our viewers, very late evening to our viewers in Europe and Africa. Good afternoon and early evening to our viewers in the Western Hemisphere, and good very early morning, as always, to our viewers in the Pacific Rim. And welcome to the Angry Astronaut. Really appreciate you folks being here. I jumped on a little bit early just so because looks like SpaceX is going to go live in about 15 minutes. So I just wanted to do some words and ways of introduction before we turn things over. So in any event, really appreciate you folks joining us. Just so you know, we have a super chat goal up there for the length of the entire broadcast. There are 20 super chats, but I am giving away 2 custom videos. In other words, 2 random people who do super chats can choose whatever topic you want, as long as it's spaceflight or UFO related, alien related, something like that. Choose whatever the hell you want, and I'll make the video. So that's what I'm giving away, 2 of those. If we can hit that goal at some point during the broadcast, and I'll tell you what that's supporting a little bit later on. So where's everybody checking in from? We have people already saying that they're checking in from various places. We have Scotland checking in. We have Texas, we have San Jose, California. This is a Texas launch, just so you know. California only launches Falcon 9s, and soon we'll be launching Vulcan Centaurs for ULA. ULA is going to start launching their rocket, assuming it works, their rocket from California. In addition to that, we have Melbourne, Australia. Thanks very much for being here. We also have Cheyenne. Really like Cheyenne, or just Wyoming in general. Hello, Malibu, and hello, New York City. Let's see what else we got. Michigan, Pennsylvania, Massachusetts. We have Tallinn, Connecticut. We have West Virginia. We have Houston, Texas. Hey, Mike, I hope you're doing well. Longtime supporter of the channel. Hello, Nevada. Yeah, hot there, hot everywhere. Hello, Dystopian, also longtime supporter of the channel in the lost island of Atlantis. Houston, England, as Harrogate, that is. We have Pennsylvania. We have Ohio, North Carolina, and I'm very familiar with North Carolina. Lived in South Carolina for 25 years. Hello, British Columbia. Well, where else we have? Hello, Farouk. And by the way, you already said another person checking in from there, so forgot to say New York. New York. And let's see, we got Philly, and we got Houston, another Houston. We got Southampton. Up, we already have the first super chat. Thank you very much for doing that. We're off to the races. Really appreciate it. Let's see, what else do we have? Let's go SpaceX. I totally support that. We need a good flight this time. Hello, Dublin, and hello, Indiana and Wales. Slovenia, thank you for joining us. Slovenia is a very beautiful place, I understand. I'd really love to go visit it. Hello, Pennsylvania, thank you so much. And Hiroshima, USA. Hello, Alabama. And thanks very much. Is it Rick or I'm sorry, I can't quite see who that was. I apologize, but whoever did the super chat, thank you, thank you, thank you. And Jack Morgan just gifted an Angry Astronaut membership. And just so you know, you will automatically get Discord membership as a result of that. Whoever just got it, thank you very much. And so yeah, that's and you get other benefits as well, but the Discord membership is the big one, and you automatically get notified as to how to do that. Annapolis, Cary, North Carolina, Fredericksburg, another. Thank you so much, Mike. That's another super chat. Boy, you guys are jumping on board. Thank you. Thank you. Thank you. Yep, we definitely need a good launch today, not just for the stock. And by the way, that helps me too. When SpaceX stock goes down, Rocket Lab stock goes down. When it goes up, they go up. That's just how the market seems to work. But it's not just that. We absolutely need a good flight so that Starship can graduate up to orbital flights. Hopefully, if they get a perfect flight out of this, because they are already applying through the FAA for these opportunities, for these for the chance to do landings in Boca Chica, to do full orbital trajectories, and then bring Starship down for a catch landing attempt at Boca Chica. Of course, they're also building new launch facilities at Cape Canaveral. A lot of aggressive action on the part of SpaceX, but we need to get off of these suborbital hops so that Starship can start doing the things that it was supposed to do. Most significant of which right now is to start doing those orbital refueling tests so that Starship can get to the moon. So Lunar Starship can do the job that it's contracted to do. And in addition to that, of course, there are many other things Starship can do. Starship can deploy huge amounts of the new Starlink satellites into orbit. Starship is going to be deploying the Starlab space station. Starlab space station was specifically designed to fit inside of Starship's massive 9-meter fairing. And of course, that's never going to go up until Starship is consistently doing orbital flights. So we need to get to that orbital step. And I am very sure that Elon and most people at SpaceX fully expected to be doing orbital flights right now, to have done several of them, probably. And so, and I'm confident they can catch up. I'm confident that they can catch up, but they need a good flight today. Firefly gets a new NASA lunar lander contract. Thank you so much for the super chat, and thank you so much for the information. Yeah, Firefly, I'll tell you, they earned themselves a lot of street cred by landing on the moon successfully on the first try with no problems. Nobody else, no private company has been able to do that. There are plenty of nations that have done it, but we're talking private companies. The only private company that has successfully landed on the moon on the first attempt was Firefly and their Blue Ghost lander, which was amazingly successful. It was quite an incredible accomplishment. So yeah, they definitely have a lot of cred as a result of that. So yeah, we will see what happens. Sure, any launch helps. Any launch helps you get more information and all that, but a launch that doesn't take you forward a big step just means it's going to take longer to get the job done in the long run. It means it's going to require more test launches to get to where we need to be. And given the fact that now Starship is operating on a timeline, if they weren't on a timeline, if we didn't need Lunar Starship for Artemis 4, then it wouldn't matter. as much, wouldn't be as important, but it's so important because of that. You know, I mean, we have the Blue Moon lander configuration as well, but that's not very mature either. And not only that, we need to get Starship Orbital and Blue Moon Orbital so that they can both do an orbital rendezvous with Orion. Orion will be catapulted into orbit by SLS and then dock with both, hopefully, both lunar landers, both the Lunar Starship lander and the Blue Moon lander next year. And according to Isaacman, he says that we're on track for that. Great to hear, but we're not on track for it until Starship actually has orbital capability. So we need an orbital flight, and I really hope that happens soon. I hope we have a really good flight today. Then I think there's an excellent chance that that Starship may be able to graduate up to that orbital capability. And as I suggested before, SpaceX is clearly anticipating that that is where things are going anyway, because they wouldn't have applied for all of these special permits for captures, you know, at Boca Chica captures for Starship, all of those sorts of things, if they weren't planning to orbit the Earth soon. By the way, folks, I'll go ahead and let you know what this super chat effort is for. And by the way, if you'd like to contribute in some other way, I have a fundraiser in the description, but let me tell you what it's all about, because I just did a fundraiser, for God's sake. So I'm not expecting that I'm going to get what I'm looking for here. I'm being realistic about this because I've asked you guys for enough help already. But the fact of the matter is, RFA-1, Rocket Factory Augsburg's orbital class rocket, is on the pad right now at Saxavord in Shetland. An historic moment in spaceflight is on the verge of happening, regardless of what happens with this rocket, unless it blows up during a static fire. This will be the first ever orbital launch attempt from Great Britain. And if they make it, it will be the first successful orbital launch from Western Europe ever in history. And right now, there's a race going on between them and ESAR Aerospace, another German company that is launching out of Norway, out of spaceport in Norway called Andoya. So these two companies are neck and neck, trying to get to orbit first, to have those bragging rights. And it's not just bragging rights, it's also the potential. It's also, and believe me, you don't have to tell me you're broke. You really don't. As a matter of fact, I don't want your support if you're in a tight spot. I really don't. Please don't give me any money if that's the case. I've said that many times. I'll say it again. I absolutely do not want your money if you're in a tight spot, only if this is financially convenient for you would I be asking for that. And the fact of the matter is that these are the funds I'm going to require if I want to cover this in person. You have to go all the way up to Shetland. You have ferry fees. And on top of that, they're not going to put me up at the spaceport this time. For those of you who remember the last time I was in Shetland, they're not going to put me up at the spaceport this time. So sadly, I'm going to have to pay for bed and breakfast fees during a high point. So we got some lag going on, huh? That's weird. And a little disappointing. I've got a great internet connection here. Not really sure why that's happening. Looks like we're doing some work. Hang on. Let me check. It appears that I'm going to go ahead and do a speed test just to be sure. Just one moment here. All right, download looks good. I've got almost 20 megs per second upload speed right now. I should be able to stream just fine with that. I don't know. I apologize. We will continue working on things from every angle to try to improve this. But yeah, it appears that we have some lag going on. In any event, though, for the good news is that SpaceX is going to be taking over here in just a moment. So that should take care of a lot of these issues. So in any event, that's what's going on. That's what this is for. So I can cover the launch from Saxavord in Shetland. And just so you know, if this is something that that folks can't support, and I totally understand why, given what's been happening lately, then I understand. This is, you know, if you want me to go, that's what's required. If you don't want me to go, I'm totally fine with that as well. I can cover it from here if necessary, although I obviously love to cover such an historic event, but that is totally up to you folks. There is a way to fly to the island, but the ferry is cheaper. And not only that, I want to bring a car. Oops, looks like we cut off there. Oh boy. Oh, we have a new subscriber. Yay! Thank you. Thank you for becoming a new subscriber. Somebody just jumped on board with us. Really, really appreciate it. Yeah, you can fly there, but it's super expensive. The ferry's cheaper, and also you can bring a car and equipment and such with you on the ferry. And obviously, that's a lot more difficult to do on a plane. All right, so producer, are we live yet with SpaceX? Let's check to see what's happening with them, please. And I will check as well to see what's going on with them and what their situation is, because they should be live here, or if they're not, they're going to be live very shortly. Okay, let's see. Just checking in to see what the... Okay, apparently not. They are on a splash screen, it looks like. Yeah, they're not live yet. Okay. So splash screen, but that's it. And yes, we are aware of the lag, but fortunately, SpaceX is going to be taken over here, and then we can work on solving the problem a little bit later on. Oh boy. Let's see here. And we have 157 watching. I'm sure that crowd will grow as we get closer to liftoff. But thus far, everything seemed... Launch time is in less than half an hour. We're looking at about 4:45 Mountain Time, 5:45 Central, 6:45. 6:45. Up, looks like now we're going. All right. Looks like we're getting ready to go, and of course we have these. We have this music, which is copyright protected, and all that other garbage. But here we go. We'll be. All right, we still got copyright music at the moment, but big moment coming, obviously, big moment. Suborbital, yes. Oh, I'm sorry. They have Starlink satellites on this, real Starlink satellites that will deorbit 20 minutes after they're deployed. Jack Morgan, thank you so much for the $5 Australian. Thank you, thank you, thank you. We got 4 out of our 20 super chats already. You guys are awesome. Thank you so much. We're getting there. But yes, we have actual Starlink satellites on this flight.
Base, Texas. It's 5:19 p.m. Texas time, and we are just over 31 and a half minutes away from Starship Flight 13, the second test flight of our next generation Starship, version 3. During our initial launch attempt last week, we had a clean countdown, loaded all propellant, and got all the way to engine ignition, where the vehicle executed a safe shutdown when its automated systems detected off-nominal startup on 4 engines. That safe shutdown ensured that both the vehicle and launch pad were kept safe. As we often say, the payload on these test flights is data, and even when we don't get off the ground, we learn some valuable lessons and improve from them. We're going to dig into the details of that in just a moment, but all of that to say is that we're here today and we're ready for our second launch attempt. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Nathan Commissary, a civil engineer here at SpaceX. Today we're coming to you live once again from just outside the Star Factory production floor, about
He's
a mile and a half from the rocket
scale
on the
t-shirt.
pad.
That is so cool.
Back in May, the first test flight of Starship version 3 delivered tons of data, and we'll be putting those learnings into practice today on Flight 2. All of this brings us one step closer to a fully and rapidly reusable vehicle, the key to enabling frequent flights to the Moon and Mars. Starship will also enhance Starlink's constellation and connectivity on Earth, the Moon, and beyond, while helping establish a network of AI data centers in space. Success on today's suborbital mission also opens the door for near-future orbital flights and our first attempt to catch ship on Tower 2 here at Starbase.
And this is an exciting day for the Starlink team as well, as we're planning to deploy 20 of the newest generation Starlink satellites. These sats aren't intended for operational use and will only be in space for about 20 minutes before demising. But during those 20 minutes, we're going to attempt to speedrun a bunch of tests, things like deploying solar arrays, firing thrusters. We'll get into those into a little bit later into the show.
Yeah, and what Starlink engineers learned today will be essential to deploying operational V3 satellites into the Starlink constellation on future Starship flights. These larger, more powerful next-generation satellites are designed to boost orbital capacity, strengthen the overall network, and deliver a noticeably better experience for our customers.
And as we've said before, Starship is a developmental program. What we're doing today is a test. We test in flight because it's the best way to rapidly iterate the design, and it's the best way to put the vehicle through its paces in the actual conditions it will experience during an operational mission.
Yeah, exactly. So while we have real Starlink satellites on board, the most important payload today is data. But no matter the outcome of today's test flight, excitement is once again guaranteed.
Now let's head a couple of floors upstairs where Dan Hewitt is just outside the Launch Control Center. How's it going, Dan?
Hey, Nate. It is going great. Hi to you and Kate. Hello, everybody else. I'm Dan Hewitt with SpaceX Communications. Happy to be here with you for another launch day. As Kate noted, our first attempt to launch this flight test last Thursday ended early in a pad abort. Let's dig into that a little bit. So 4 of Super Heavy's 33 Raptor engines aborted at startup due to issues with their aux turbo pumps. Those rapidly pressurize and feed liquid oxygen into the engine for combustion. For those of you that like to pay real close attention to the on-screen telemetry, you saw this at T0 during that first attempt. We command the engines to start up simultaneously. You get some slight differences as the engine adapts in real time, but you saw 4 not light up. So 4 out of 33, what exactly happened? We have a launch constraint built in where we can only be down 2 Raptor engines at liftoff. So the vehicle detected more than that were out, automatically aborted before the final T0 safely shut down all of the engines that started up. We dug through the data, and what we saw was some off-nominal spin response in the aux turbo pumps on 6 of the engines. So the most likely root cause was determined. We were collecting some moisture inside of the pumps from previous operations, which then froze when we introduced that cryogenic propellant, and that either slowed those pumps down or stopped them completely from spinning. So for this next flight attempt, we swapped in 6 engines that were already at Starbase, and we did a test back on Wednesday that allowed us to check out the newly installed engines and spin the aux pumps on all 33 after they were chilled, check out their performance before we got into another launch attempt. We pulled a bunch of those engines off, as we said. We tested one on a test stand up at McGregor, helped screen for any other issues that might be hiding, and that one was actually able to do a full booster ascent burn. So got us in a good position for today.
Thank you so much, Alpha Sigma.
Even though we didn't get off the pad last week, we learned about the engines, the prop systems,
so
how they perform in the flight environment.
Thank you.
Already going to drive some changes to make Starship more reliable. We also got a real-world test of an abort that's designed to take place at one of the most critical, dynamic phases of flight. We safely shut down 29 running Raptor engines, safeguarded the vehicle and the pad. A mountain of work goes into designing aborts. You've got software, hardware engineers just dreaming up bad day scenarios, how we want the vehicle to respond, just to give us the best possible path to maximize safety, preserve the mission and the hardware, so we're able to do that. All right, that was then. This is now Flight 13's second attempt. So things are looking really good at the moment. Just behind me here is the Launch Control Center. Everybody's on console, looking at the systems on board the vehicle and on the pad as we count down to liftoff. Propellant load is underway. We slipped a little bit into our window as we waited for some last couple of things to settle out, and we are targeting a liftoff at 5:51 p.m. Central Time. Weather today, you can see we've got blue skies. We're going to do a little weather corner here for a second because we were originally attempting to fly yesterday, and we didn't because of, we said, weather. I want to be clear, the cause of not flying was visibility. It had nothing to do with launch weather constraints. One of the key goals of this flight is to get very clear imagery of the tiles on Starship as we're flying it at a higher dynamic pressure. You can't do that when you have clouds completely obscuring your view through all of those critical phases of ascent. We're actually capable and legally allowed to launch into lightning because we've done a ton of testing, unique testing, analysis, studying aircraft capabilities, and it's designed because that's ultimately the cadence we want to fly at, like an airplane. We're going to utilize that new capability carefully, but we're very aware if we want to fly Starship as often as you could fly an airplane, you're going to have to fly in weather that historically would keep rockets on the ground. So we're doing that analysis, we're doing that testing to prepare for the future. Aside from weather, we're watching the range, both in the Gulf right here off Starbase and in the Indian Ocean. That's currently green. And we are not tracking any vehicle or pad issues that will preclude a launch today. Speaking of the pad, that launch infrastructure, it's every bit as complicated as the rocket itself. It's designed to operate in some of the most extreme conditions on Earth. In case you missed it, we had some pretty cool insight into what it takes to launch the most powerful rocket on the planet in the second episode of our ongoing documentary, Starship.
Oops. I think we might have some music here. Sorry about that. Wasn't immediately apparent to me. So apologize for that. It's definitely got music. So we just checking in on everything. We looking at just under 23 minutes or so. Yeah, it's exciting already, obviously. Oops. Do we have... This may just be from my side. I'm never sure what's going on. No, it must be from my side. Just my paranoia. We're under 23 minutes at this point. Let me see. Let me check some of the questions here. Oh, wait a minute. Never mind. Are we... Yeah, I think the music's gone, so we can bring them back, I think. Or not. Alpha Sigma, thank you so much for becoming an advocate. Thank you, thank you, thank you. Yeah, the venting would be liquid oxygen. That's what's going to be the most visible thing that you're going to see during a fueling process. Thank you for joining the advocates. By the way, if you become an advocate, that means that you get to be part of the Discord team. You get Discord membership, and you are automatically notified as to how to take advantage of that. And Mr. Steve, thank you so much for the tenor. Really appreciate the support, mate. Really helps, let me tell you.
amount of energy that water can absorb
The
is
deluge
like
system is
miraculous.
crazy.
And so if you can get high enough pressure water in the right places and just allow it to flash boil that water, then it solves a lot of the problems for you. Like the idea is that the steel never gets that hot. The structures never get that hot because the water absorbs all that energy, turns to steam, and everything's okay.
So for this flame deflector on pad 2, we're sitting somewhere in the neighborhood of about 600
Buffalo, they are launching from Boca Chica, Texas, close to South Padre Island.
Except for instead of shooting bullets, it was shooting pickup trucks, and it's just firing 11 pickup trucks per second out of the bottom of the rocket. It's like, do you think your stuff could survive that?
To watch the slow motion flame diverter shots.
Right, and just hear all the exciting stories of how we tackle these problems out here in Starbase. Super exciting.
Yeah. And by the way, if that looks like fun to you, come join our team. We are seeking scrappy problem solvers to help us build the future. Okay, let's go meet the rocket out on the pad, Starship version 3. It's the most powerful rocket ever developed and ever flown.
And it's also the tallest at just over 407 feet tall, fully stacked. It is massive. Standing at the base and looking up is like looking up at a 40-story building. Incredible.
Yes, it's a two-stage rocket. Both stages are designed to return to Earth and fly
Coming
again,
up in 19
making
minutes.
that thing that you see on your screen the first fully reusable rocket ever. The bottom half, or the first stage, is the Super Heavy booster. That's the silver part. It's powered by 33 of our newest iteration, you see them there on your screen now, Raptor 3 engines. They run on liquid methane and oxygen, and this version of Raptor provides a significant increase in thrust. With that additional thrust, as you can see here by these comparisons, the version that we're launching today, version 3 on the far right, that version of Starship gets off the pad much faster than our previous versions. The one on the far left is, I believe, is actually our Flight 1 footage, and in comparison, they really just go.
Yep. And now Super Heavy has 3 grid fins, which you can think of as aerodynamic rudders. You see them on your screen now. They help steer during landing. They're 50% larger than on previous booster versions and are designed to support rapid reuse and a more stable atmospheric reentry.
Amen, Professor.
I love that shot there. And at the top of the booster, we've got the hot stage adapter. It's designed to protect the booster during separation.
I'll talk about
and now
Saxavord
it's fully
later.
integrated for reusability.
And stacked right above that is our upper stage of the rocket, or stage 2. It's what we call ship. It's powered by 6 Raptor engines, 3 optimized to sea level performance, and 3 for the vacuum of space.
Ship's design could one day enable point-to-point transfer on Earth, meaning you could travel anywhere on the planet in an hour or less. Sounds pretty great to me.
Sounds awesome.
It's designed to carry massive orbital payloads, both cargo and crew, to Earth orbit, the Moon, Mars, and beyond.
And for the first time, we are carrying real Starlink V3 satellites to space. For more on that, let's head out to California, where Tyler is standing by with the team in Hawthorne. How's it going, Tyler?
We're doing great over here, Nate. Thank you both. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Now, for those of you who have been following along, the Starlink version 3 satellites have been designed to take full advantage of Starship's payload capacity. And we're going to get our first look at those satellites today. The Starlink V3 is our next-gen satellite, and it includes meaningful increases in capacity, data density, and power generation. So we'll be adding around 20 times the capacity into the constellation on each Starship mission as compared to the version 2 satellites that we launch on Falcon. And that means that we'll be able to serve more people all around the world and with increasingly better high-speed internet. Like all Starlink satellites, the
Thank you
V3s
so
are built
much,
at
Airborne
Starlink's site
Bob.
in
Thank
Redmond,
you,
Washington, where we
thank you
already
for your
build more
support.
satellites than
That's 6
anyone
out of
else in the
20
world
super
today.
chats. Good
Now,
job,
the
guys.
V3 sats are designed to support 1 terabit per second of downlink and 160 gigabits per second of uplink capacity. That's approximately a 10 times improvement in downlink capacity and around a 22 times increase in uplink capacity from the version 2 Starlink satellite. Serving this capacity to and from customers are the satellite's upgraded phased array antennas. The upgraded phased arrays are fed by SpaceX's in-house developed chips that were designed to serve customers more efficiently in both densely and sparsely populated regions simultaneously. And each Starlink V3 satellite is also equipped with 6 high-capacity 400 gigabit space lasers. Now, these 6 lasers will allow high-bandwidth traffic to flow uninterrupted between any 2 points in the world with redundant paths across a petabit laser mesh network. And if that wasn't enough, the V3s will carry 4 quad-band radio frequency backhaul antennas. And these will take advantage of the Ka, E, V, and W communication bands, allowing for an 8 times improvement in supported capacity compared to the V2 sats. And that's a lot of growth in capacity and capability. And as such, the new satellite design requires more power.
Thank you so
the
much,
solar
is it
arrays on
Darking?
V3
Thank
will
you.
generate approximately twice as much
Darking
power
asked
as
us,
the
I
current
guess. I'm
arrays that we
sorry,
fly on the
but
V2
thank you so much for the
satellites.
compliment.
And they're also optimized to reduce drag in the lower orbital altitudes in which these new satellites will operate. But before we operationalize these satellites, we want to put them in a flight-like environment. These satellites were loaded into Starship last week ahead of that first attempt. And once deployed, the Starlink team will only have about 20 minutes of flight to speed run some of these tests before the sat's demise in the atmosphere. The team will attempt to run tests
15
such as
minutes.
extending the new solar arrays and antennas, connecting with ground stations, and turning on the satellite's communication systems. And this is all part of SpaceX's iterative process to technology advancement. From the very beginning, Starlink was designed to scale rapidly and improve continuously. From production to launch and ground infrastructure, Starlink is uniquely positioned to keep pace with rising demand around the world. In fact, just last week, we rolled out the next generation Starlink kit, the V5, which is built for reliable, high-speed home internet.
Yeah, Long March got hit by lightning today, the Chinese Long March rocket, on a satellite deployment. However, as far as we know, no problems whatsoever with that. Not much to report on, really. They may decide to change things a little bit, given how scary that probably was for them. But it's, by the way, that is the reason why these companies, why launch providers avoid launching in these kinds of conditions. China had to learn that lesson, and they learned it today. Alpha, thank you so much for that. Another super chat. And it's Wiley. Wiley, thank you so much for the super chat. You just popped in there as well. Thank you. Thank you. That'll take us to 8 out of 20.
Bunch of stuff really focused on what are the 3 limiting factors to making data centers in space a reality. First one we talked about was mass to orbit. That's where Starship comes in. We're going to need megatons into low Earth orbit, and we're going to be combining its full reusability and the really big payload capacity to launch the number of satellites that we're talking about, because we plan to deploy up to 1 million AI satellites, and those are going to function as those orbital data centers using Starship for the high volume, low cost launches. A couple of really key reasons why moving data centers to space has advantages over building them here on Earth, which gets into our second limiting factor, which is power generation. It's always sunny in space. Satellites can harness
so much, Jacob.
that sun, that near
Really
constant
appreciate
solar
what you
energy,
just said there.
which is really going to be the only way to scale if AI continues to grow at the pace
halfway
that
on
we
the
see,
super chats, guys,
especially when you
Starship
contrast it with
hasn't
all
even
the
lifted off
challenges
yet.
that
You
you
guys
have
are
here
awesome.
on Earth. Within about 2 to 3 years, we believe space-based AI compute is going to become the lowest cost option as those launch costs continue to
true,
drop.
Professor.
And
They
Earth-based
didn't
constraints
live
continue to
stream the
grow.
Pegasus
It's going
XL.
to just
No
transform
idea why.
how Earth powers AI, unlocks the future. And then our third limiting factor that we got to go figure out is going to be chips, and we got to do that fast. And that's what we're doing with Terafab. That's going to be the most epic
Mark,
chip building
thank you
effort
so much for
ever.
the 10 euros.
Not just
Thank you.
churning out really cool advanced chips, but
Wow.
also building
Super
a
chats
massive scale
flooding in. You guys
location
are
to do
awesome.
it. We're
Thank
talking
you.
100
And
million
yeah, I
square
do get
feet,
stressed
so
out
about
anytime they
10
talk about more
Tesla
satellites, especially
gigafactories.
a million
All
of
of
the
this
stupid
together
things.
sounds
Just make a
a bit fantastical, a
data
bit out
center
there,
in
but these are
orbit, big
real
data
steps that we
center
are taking
space
right now
station or something
that
like that.
are going to set us up to
Yeah.
eventually become a galactic civilization. That sounds really cool. I mean, harnessing meaningful amounts of power from the sun, supporting all of those AI applications that are going to change our daily lives, and making humanity a multi-planetary species. If you want to learn more, you can watch the full conversation on our website. Hopefully a link appears on the screen. If not, go look up StarMind. So the future is looking pretty sweet, but first things first, we've got Flight 13 ahead. Let's jump down to Kate and Nate for what's ahead.
Thanks, Dan. Yeah, the future is built on progressive steps like today's test. So let's dive into the flight profile that we're going to see today.
That's right. We've got an exciting day in store. So starting with liftoff, Super Heavy will ignite those 33 Raptor 3 engines right off of Pad 2 here in Starbase. We will then power through ascent ahead of hot stage separation, where the booster will shut down all but 5 engines at the bottom. Stage 2 will then light its own Raptor engines, pushing off from Super Heavy and starting our stage separation maneuver known as hot staging. We will then have the directional booster flip using 33 engines, and after coasting for a few minutes, the booster today will target a landing burn and ocean splashdown a few miles off the coast of Starbase.
Ship is going to keep the party going with its ascent
okay,
burn to
Cat,
a
that wasn't
suborbital
much of a
trajectory,
cuss
followed
word,
by
really.
deployment of those 20 Starlink V3 satellites. We also plan to relight a single Raptor engine. Re-entry is just a few minutes later, which should provide some amazing views thanks to Starlink. And
Sigma,
typically
thank
we
you.
see
Yes,
some
indeed,
pretty
Lucky
fantastic
13,
views of
let's
the
go.
ship's
We need
blistering
a
re-entry
perfect flight
through
this
the
time,
Earth's
guys.
atmosphere. A plasma blanket will form around the vehicle and never prevails to
Yes,
provide epic scenes.
full tiles, as
And lastly,
far as
we'll
I
conclude
know.
today's test with a landing flip, a landing burn, and a splashdown in the Indian Ocean. And with that, let's kick it over to Dan for a countdown update.
Thanks, Kate. Good news. We just heard from the flight director. We are T-minus 10 minutes. We're a little bit past that now, not tracking any issues for launch today. Range continues to be green. Our range team hard at work, making sure we're clear out in the Gulf and in the Indian Ocean, where we're going to be sending the Starship.
Yeah,
weather
Matt,
continues to
Professor,
be
I have
gorgeous.
no idea
Again,
why they didn't
no
do a live
clouds.
stream
We
of that.
scrubbed
I
our
think they
attempt
actually
yesterday,
did a
or
live
didn't
stream
even
of one
try
of the
yesterday because
attempts
we
that
had
didn't
such
make
poor
it.
visibility.
Then they
Weren't
stopped
going to be able to see
streaming it.
those tiles
Again,
on the way
I
up.
don't know.
That's a
I really
key
don't know.
kind of experiment objective for this flight today. And so we're looking really good with weather today. In the future, we'll see what kind of adverse weather we can fly into. We are capable and allowed to launch into lightning, but we're going to utilize that new capability carefully as we eventually
true,
continue
Natalie.
to
Could be
evolve Starship
vaporware.
to fly it at an airplane
There's a
like
lot of that
Cadence.
in this industry.
You can see the prop load there on your
9
screen.
minutes,
We're
guys.
just about closed out on the
9
main
minutes.
tanks on the ship. We just started propellant load in the header tanks
Johnny
on Starship.
boy, thank
Those are
you
the two
so much
smaller
for the
ones up top
fiver, my
that we'll
friend.
hopefully
Thank
be
you
using for the
so
in-space
much,
burn and a landing burn at the end of its mission. We started loading our propellant at about T-minus 35 minutes today, and we're going to continue all the way down until we're inside 3 minutes to launch. We'll close out at about T-minus 2 minutes and 50 seconds on booster, and then 2 minutes and 10 seconds on the ship. So at the moment, we're looking good. That launch time,
Getting
5:51
tense. We're
p.m.
getting close
Central,
here.
a couple of minutes into our window today. So we'll be back real soon. Toss it back down to Kate and Nate.
Thanks, Dan. Recently, NASA announced the astronauts for the upcoming Artemis 3 mission. The Artemis 3 mission is a crewed demonstration
It
mission
wasn't that
in low Earth
recently.
orbit designed to demonstrate critical systems needed for future lunar landings. Astronauts Andre Douglas, Luca Parmitano, Randy Bresnik, and
8
Frank
minutes and
Rubio, as
counting.
seen there on your screen. They will crew the mission, and it's slated for 2027.
It's a great crew, and it's also the penultimate mission, the final test before Artemis 4 attempts to put astronaut boots back on the moon for the first time since 1972. We'll be launching a Starship with a docking port on the nose so we can practice rendezvous and docking with the crew. And one key test objective comes after docking, where we will be able to test out maneuverability of the vehicles together while in space. This has the new importance as the revamped plan for lunar landings use Starship to do the burn, sending astronauts to the moon from Earth orbit.
And one other cool
cannot
ad,
stop
NASA
talking
is
about
putting
how much
2
that
SpaceX
pisses me
mini
off.
lasers on Orion to connect it
You're
to our
using
Starlink
SLS
constellation
anyway
with
to
the goal
get
of enabling
Orion to
4K
orbit.
imagery
You're
and
spending
video
all that
from the
money
spacecraft
anyway.
while
Why
in
are you
space.
bothering
So
with
that's
it,
going to be pretty
handling
awesome
the
to
bill?
see.
Awesome views for sure.
Yeah, there's lots of excitement planned for next year as we all work together
Mr. Boo,
to send
thank you
humans
so much
back
for the
to
10
moon.
euros. Really,
And
really
speaking of
appreciate
sending
it.
humans to
Thank you
space, former
so
SpaceXer and current NASA astronaut Anil Menon is actually up on the space station right now as part of Expedition 74, and he captured
Cat,
these
please,
sweet photos of Starbase
I
during an
emphasize
ISS
this
flyover.
again. Please,
Hi, Anil.
nobody
We're all
ever
waving back at you,
apologize for
buddy.
not doing a super
It's awesome
chat.
to see
I
the whole
only
picture
want you
here
to do that if
as
it's
there's lots of
convenient.
facility and
If you're
infrastructure
in a
development
good
going
place
on,
financially.
but
If you're not,
Starbase isn't
please,
alone on that
please.
front.
Yeah, it
Break
changes
my
every day.
heart to
Yeah.
take
But
your money if you're in
talking
a tight
about other
spot.
locations,
So please
work
don't
is
do
well
that.
underway in Florida to
Otherwise,
get pads
thank you, 'cause
39A
this is
and Slick
so helpful
37A
for my
ready
next
for future
objective in
Starship
getting to
launches
Shetland
potentially later
and
this year.
covering this
Starship
launch.
launches from Cape Canaveral are key
Thanks
to hit
so
the
much,
necessary
Johnny's
launch
for the
cadence to
5
get back to the
Australian.
moon, build a moon base, head to Mars,
Oh,
all the
YouTube
exciting
TV,
stuff
huh?
ahead in the future.
Interesting.
Yeah, exactly.
I need to find
and
out
that
more
future
about
gets
that.
closer and closer with tests like today's flight. And with that, we are just under 6 minutes until launch. So that brings us to terminal count. Excitement is definitely getting traction down here as the crowd is gathering just behind us on the lawn outside, and happy to say, still not a cloud in the sky. Dan, how are things up at Mission Control?
Things are still looking really good, Kate. We are still not tracking any holds on the board. No issues with
Sigma,
the
thank
vehicle
you.
or with the pad.
Thanks again, man.
Our range
Jumping in with a lot
continues
of
to be
super chats
green,
today. Thank
both
you,
in the
thank
Gulf and out in the Indian Ocean for flight today.
Well, they
continue
can't
monitoring that
demonstrate
all
the
way
catch of
down,
the Starship
into the
because
final
Starship would
minutes.
have to orbit the
We
Earth
are going to be
entire
closing out our
completely
propellant
before it
loading
can come
on the booster
back
and the
down
ship
and try to be
within the
caught.
next
They're
3
not ready
minutes.
for that yet, and the
We're gonna
FAA
have
hasn't
about
approved it
11.5
yet. The reason they're not going to
million
try to
pounds
catch
of
the
liquid
booster
oxygen and
again
liquid
this
methane
time
on both
is
of those
because if they
stages
crash
once
the
we're all
booster
done.
into one
Then
of
it'll
these
be
launch
time for the
facilities,
pad to
it would
essentially
be
ready itself,
devastating. It's not
where we clear
necessary
out
to
all of the
take that
prop that's
risk
been
at
flowing through feed lines
this
up into the
time.
launch mount, up into the
So
tower.
I think
Those
that's
go
their
back into the
motivation
propellant
right
farm,
now,
get
is
it
even
ready,
though they
and
need
we'll
to
do
practice,
those final thrust
I
vector
don't
control,
know if they
those steering
want to
checks
take that risk
as
at
we
this
get a little
point.
bit closer.
Less than 5 minutes
If
to
we
go.
need to hold that hold time, it's new for this launch, and we saw it briefly on our attempt last week. That hold is set at T-minus 60 seconds now. That's where we can pause, we can wait.
All right,
We
we're
need
under
to
that.
just
5
kind of
minutes,
hang out
guys.
for any
We're really
pressurizations,
close.
anything like that to clear. We've got a couple of minutes to hang there. We will only hold if there's an issue, and we're not tracking any holds on the board right now.
That's right. Now, once T-minus 60 seconds passes, a number of events will occur in rapid succession. Both the ship and booster will configure their comm systems for flight, and they will rapidly run leak checks on gas and fluid tanks. Meanwhile, the booster will be going into internal power, and its engines will get their final priming for launch. Those ship engines will also begin their ascent bleed profile, and it will arm its automatic flight safety system. There's a lot of mechanical activations on the tower side as well, with
just
one
me.
critical step
Thank
being
you. Thank you.
unlatching
You're right.
of the
Hopefully
quick
you're right.
disconnect, feeding
Third
propellant
time's a
into the ship.
charm, and lucky 13.
And once T-minus 60 seconds has
Fingers
passed,
crossed.
we still have the ability to
We're at
rapidly
about
recycle
3.5
the count
minutes
under
now,
certain
guys.
conditions back to that T-minus 60 seconds point and hold
Here
there
we
to
go.
assess what happened. And
Okay, we had just a momentary lapse, just a second. We're going to get that back for you. Just getting that stream back. I think we had to do a refresh, maybe because of the lags.
now, for those that have
So
just
we're
recently
we're
tuned
refreshing it
in,
right
once
now. There we
again,
go.
our
By the
primary
way, I
test
didn't do any of
objectives
that.
for
That was
today's test
producer
flight
who got that
includes
all
a
back
successful
so
liftoff,
fast.
stage
Everybody
separation.
say
We also
thank you
plan
to
to
producer
deploy
ASN,
20 Starlink V3
who
satellites. We have real satellites on
does such a
board.
great job.
We expect
Because
to
of you,
have about
because of
20
your
minutes of
generosity,
available time to
I
speed
can now
run
pay
some
a salary for the next
tests
6
and really
months.
allow the Starlink engineers to put them to the test in that time.
That's right, and we also have the soft splashdowns planned for both the booster and the ship. Going to be super exciting to see if we can return those safely back, so that way we can get ready for tower catches again.
2.5 minutes.
And just a quick check-in, we got our final green light from the range, not tracking any issues on ascent or out in the Indian Ocean for entry. So that was kind of the final go for flight that we wait for in these final
We're
minutes.
just pausing the ads, I think,
Prop
right now,
load
guys,
closing out
so we can watch
on both
the launch
vehicles. We have no
totally
holds on the board.
uninterrupted.
Again, that we've got that gate at T-1 minute. We're only going to hold if there's a reason, and
Thanks,
currently there are no
Spacesuit.
reasons.
Thank you so much.
Now, coming up here in a few seconds, we should have, oh, actually right there we can see on screen, that's the base of the Super Heavy booster. Those are the 33 Raptor engines, and we expect to see and there they go, the TVC checkouts, also known as engine wiggles. We're activating those thrust vector control actuators to ensure that those
Just
center
over a minute,
engines
guys.
and the inner radius
So far,
as well
so good.
have
No
the
signs of any
ability to
problems.
steer the rocket.
Yep, super cool to see how fast those move. I mean, in flight, it's amazing to see how it steers the vehicle. And we're coming up on that T-1 minute now on our countdown, so let's listen in to see if we pass that gate.
All right, we are through the gate. Still no holds on the board. 50
Here
seconds
we go, guys.
to go. Starship getting ready to fly.
Here we go. No problems. Godspeed, Starship. Go, Starship. Go, SpaceX.
Flight tractors go for launch. -9, 8, 7, 6, 5, 4, 3, 2,
Here goes the deluge. Ignition! And liftoff. Beautiful. Beautiful. Oh my God.
Vehicle is pitching downrange.
Spectacular.
Booster Raptor chamber pressure's nominal.
Seconds
All
into
33
flight.
engines
33 out of
lit
33 Raptor
and
engines
looking
lit on
good.
the Super Heavy booster, arcing away from us here at Starbase.
Off to a good start here, guys.
Coming up on max Q,
Want a perfect
maximum
flight. This is a
aerodynamic
good way to
pressure,
get
which
started.
again for this flight is going to be higher than it has been on any of our previous Starship flights. Right, so we're passing through that maximum aerodynamic pressure over a minute now into flight. Still seeing 33 out of 33 Raptor engines lit and burning. Our next
These
major
engines
moment is
are
going to be
doing
coming
very
up
well
in
so
just
far.
a little over
Wow.
a minute from now, when we're going to get to hot staging. We're going to shut down all but 5 of those engines
Hot
on the
stage
booster. It's
separation
our
coming
version
up
of MECO.
soon.
Most engines cut
Man,
off.
this is impressive
And then
so
we're
far.
going to ignite the 6 engines on the ship while it
We
is still
need a
attached
perfect
to do
flight.
that
This is how we
separation.
get it.
As a reminder, we try to do a directional flip, so when you watch on your screen, we're hopefully going to be sending that booster towards the bottom of the frame. For the booster itself, it's like doing a flip up. It'll go towards the bottom of your frame. We do that by lighting the engines in a slightly staggered sequence. Standing by for hot
Things are
staging.
going so well so far, guys. Going so well. I can't see the name on that, but thank you so much for the
All but
$10
5
super
engines
chat.
down.
Thank you.
6 ignite.
Burn startup.
Separation, hot staging. Very nice. No
booster
signs of
now
any
doing its
problems.
boost back burn. It looks like we lit all
Yep, they're
33
dropping down the
initially. Now we're down to
appropriate number of
13. We're
engines.
seeing
This
6
time,
out of 6
everything
Raptors
looking
lit
good.
on the ship.
This may be down to 3 engines, just like it's supposed to.
Back burn shut
And
down.
then down to 0, which again is exactly as is anticipated.
Back burn
6
shut
engines
down.
burning
So it looks like we
on
were able to get them to boost
Starship.
back burn this time around.
Man,
it was one of the key objectives
it
we
doesn't get
didn't
much
have
better
on
than
the
this,
last
guys.
flight. And we've got 6 engines lit on the ship.
So far,
All right,
so good.
that's the
God,
first
this
of 2
looks good.
burns that the booster is going to be doing to kind of send it back towards us. It's going to be landing a couple of miles offshore from Starbase, hopefully. We're going to try and get it all the way down to do a landing burn, where we're going to use those 13 center engines. They're going to ignite. That's what's going to really bleed off all that velocity that it's built up. And it'll eventually, hopefully, transition to 5 engines to kind of
This
fine-tune
is
its path in.
very
And
impressive,
then all the way down
folks.
to 3.
This is the
for the
kind of
remaining
flight
bit.
we need. And yes, it is a practice flight.
All right, we've got a couple of minutes to go.
Yeah, so
until we
far,
get
yeah,
there.
this is our
So
best
booster's gonna
launch
coast
yet.
for a little bit.
No engine
Ship
failures
still seeing 6
anywhere.
out of 6 Raptor
Every
engines
perfect
lit. 4
separation,
minutes into the
proper
flight. Ship's got
descent
about
on
4
the
minutes left.
booster.
Getting some killer views.
This
Kate,
is
Nate,
all
how's the
looking
view from out
very
from
promising.
down there.
And
It
again,
was
this is
incredible.
absolutely
I mean,
what we
it just
needed
shot off the pad and
from this
seeing all the
flight.
crowd
We
now
had
running
to
back
get to
inside
this
to take
point,
views on
and
the
we
screen
are.
here.
Our
It was
SpaceX
amazing.
is.
Yeah, one of these days I'm gonna learn to not
But for
stare
all
at
of
the
our
engines,
benefit,
'cause now I
for
have
those
a
who want to go to the
bright
moon,
blob
thank
in
you
my
so much
vision.
for that $20
But now
super
speaking
chat
of
that
vision,
just
we
jumped
can see,
across. You're a
both stages
legend.
there on your
Alpha
screen.
Sigma with another
Starship
super
second
chat.
stage is
Man,
still
you guys are
firing its
fantastic.
engines. You can follow along
Thank
with
you,
that
thank you,
with the
thank
GUI
you.
down on the bottom right-hand side of your screen. Still following the planned flight path as
All right.
well. Beautiful views of planet
So
Earth
we
there
just switched
behind the
around.
ship.
Boy, they're right off the coast, too. Really,
That's
no
right, and we're actually
problems
getting
with
a
the
live
booster,
shot off
near
the
as we can
booster right
see.
now,
Oh,
an
that's so
onboard
cool.
camera. You can see the plume from Starbase where it just lifted off 5 minutes
Yeah,
ago.
the booster could not be better positioned. They were just commenting
We
on how
are
you could
there.
see the
We
plume
are
and all
there.
that.
That is us.
And it's
I kinda wanna run back
absolutely
outside and
true.
wave.
Right.
That they could
Now,
not
again,
ask for
this
better
booster is not
positioning from the
planning to come
booster at the
back to the
moment.
tower or to launch site for
Very
this particular
impressive.
launch. We are going to be planning to do an ocean splashdown just off the coast of Starbase. So hoping to still
Yeah,
get
this
some amazing views of that.
man, this is what we needed. Man, this is what we needed.
Pretty awesome to see the Raptor engines there on the left-hand side of your screen. We can actually see the plume there of those center Raptors. Those are the sea level ones, as well as the vacuum Raptors are the 3 on the larger ones on the outer radius.
And again, all 6 engines on Starship.
Now, just
Going
like on
perfect.
tower catches, we are going to be doing a 13-engine landing
at
burn.
this
to slow the
stage-
booster down. Hopefully, we can
At
get
this
a live camera of
stage,
the
this
booster
is
right
looking
now
as
we're
perfect as it
going
can
into
get.
that phase.
Hopefully, that.
Awesome shot. You can see it there. So right now the booster is
Just me,
using
thank you
3
so much for
hypersonic
another
Griffin's to
super
guide
chat,
itself
man.
through the
Thank you,
atmosphere
thank you.
toward its landing site.
Earth is
You can
not
see we're
flat,
only
yeah.
5 kilometers above
True
the
enough.
sea right here.
Again, this descent looking very good. It looking like it's
Just
exactly
wanted to call
where
out
it
for
should
landing burn
be. I
startup
don't
for the booster.
foresee there being an issue here. I mean, it depends on if the engine's light. We'll see what happens to these
Go
engines.
wild here.
Engines
And
lighting.
another awesome landing
Looking
for
good.
Super Heavy.
Oh, I don't know.
Congratulations
The
to all
engines.
teams
Oh,
here
I
at
don't know.
Starbase and at
I'm not
our
sure if those
SpaceX
the
team.
engines are going where they're
An
supposed to be.
amazing,
No,
amazing view.
that was kind of an ugly
Everything continues to go
splashdown
well with ship,
with
as you can
only
see there on
5
your screen.
engines relighting. Damn it. I mean, a relatively
Yeah, we've
minor
got
thing, just to
about
be
a minute
clear,
left
but only
with the
5
ship engines
engines
on. Just
relit,
looking at
and
the
I
booster real
don't
quick,
think
it didn't
that
look
was
like
the
we
distribution
lit
of
all
engines that they were
13
looking
engines that we were
for,
planning for
and
that
it pretty
initial
much
landing
plunged
burn. We were
straight
targeting
into
a
the
softer
ocean.
splashdown.
Definitely
As
not
you
a
saw, it
smooth
came in with
landing.
quite a bit of velocity still. So
Yeah, too
landing
bad there.
velocity did look a
But
little bit
again,
high,
it was better
but
than last time.
really cool to make it all the way back this time to the
damn
landing
it.
burn. We'll dig in,
I was
figure out
everything
how to
was
turn on
looking
all those
so
engines
100%
and then
perfect.
get to a full landing soon. But all eyes on ship. We are
But given the way
just
they were
a little
talking,
ways
I'm not
away
even
from
sure
getting
that they
those
were
engines turned off.
feeling
We expect it to
100%
burn about 8
confident
minutes and
on the
change.
landing burn and
And
all
so
that.
hopefully just about 15
So
minutes
I
to
don't
go.
know. They may have
Sounds like we
been.
just got the sonic
They may
boom
still have been
here at
struggling a
Starlink.
little
That was
bit with the
awesome.
booster,
splash
the
down.
Raptor relights, or the propulsion system in the booster.
And engine shutdown.
All right, so we got an engine shutdown on the orbiter, and that's looking good, guys. And
All right,
in my
Starship
opinion,
6 Raptor
based on how
engines
well the
have
orbiter's done
successfully shut
in
down.
other flights, I
And there's our
think that
call
that's
out for
going to
nominal
work well
orbit
here.
insertion.
I'm
So
going to
we
make a
got a ship
prediction,
in
and I
space.
think that other than that violent splashdown in the ocean, other than that, I think we might be looking at a really good flight here. But let's see what happens. We got to deploy engines, and there has to be a relight of one of the engines as well in order to get the ship ready for orbital refueling.
For the launch and after. So we're getting ready now for our in-space.
It was nice of him to
Yeah,
make
we got
that
a few
clear
minutes
that
until the next
there was nobody in
milestone, so-
danger there. That booster came down a lot more on target than the previous one. Yeah, the splashdown, it just slammed into the ocean and blew up. I mean, that's what had to have happened. And chances are there were people on shore who captured that. As a matter of fact, producer, if you have a second, if you can start scanning X and see if anybody's posted that, I would say there's a decent chance that somebody's already caught sight of that booster plunging down and captured that impact. All right, so apparently you got some music now, and it's going to be a little while before we get to the other steps of the mission, because we have deployment of actual Starlink satellites. Although, to be clear, they will not be functional. The rotation may just be a function of positioning Starship properly for the deployment of the Starlink satellites. In my opinion, that's probably what's going on there. I don't think it's anything unusual or anything to be concerned about. They just have to make sure that it's positioned so that deployment bay can be in the right position. In addition to that, they're gonna, as I say, they're going to have to relight one of the Raptor engines on the upper stage. I can now. Yes, go ahead. Heard you for a moment, and now I don't hear you. Sorry, I've got a member of my team trying to talk. All right. Not sure if we've had somebody who may have noticed something. I'm not positive. Okay. I'm seeing a lot of firing of the RCS thrusters. I don't think there's anything to be concerned about there. They may just be testing maneuverability more than anything else. They do need to deploy the satellites. So that's going to be that requires some maneuvering. Farouk, I don't think it's out of control. If it were, we would see more of a flipping maneuver. I don't know. I could be wrong here, but I think that Starship is simply maneuvering in order to get into position for Starlink satellite deployments. And again, to be clear, we're going to be looking at about a 20-minute time frame for these satellites to be in orbit before they're just going to, before they'll deorbit. Yeah, I don't know. Again, I've been wrong about these things before, but I really don't think Starship is having issues here. I think all of this is attitude adjustment so that it can get into the proper position for satellite deployment. I really think that that's all that's going on. It's firing those RCS thrusters in order to get that proper maneuvering. And of course, they have to do a lot of RCS thruster testing simply because it's not going to be long before they're going to be docking with Orion. Will anything change for Flight 14 because the booster failed its landing? In my opinion, it shouldn't. Okay. In my opinion, they have enough here to attempt an orbital flight. I don't see why, because they can attempt a booster landing on an orbital flight as much as they can on a suborbital flight. So in my opinion, they shouldn't have to do that for an orbital flight, but we'll see. I don't know what they're actually going to do here. And also it depends a lot on what's happening with the rest of this flight. Very interesting, man. I'll tell you, there's a lot. Yep,
Now,
there's
for
nothing
those of you
wrong.
that perhaps
There's nothing
missed
wrong,
the,
guys. If there
previous
were, they would
14
say
minutes,
so.
This is
Is all
flight of
attitude
Starship
adjustment
version
to get
3.
into
This
the
is
right
flight
position to
13.
deploy
It
these
lifted
Starlinks.
off. It had a beautiful ascent as well as a ship ignition and stage separation. It was literally picture perfect from here in Starbase.
Picture perfect, and then we continued with that booster hot stage separation. Amazing to see some live replays of that. And of course, the booster performing its own boost back and landing.
Yeah, ship continued for about 8 minutes with all 6 of its engines and made it to second engine cutoff, where we heard good orbital insertion, and we've been coasting in space for the last few minutes. Now we're getting ready to deploy our very first real Starlink version 3 satellites. The door will be opening here in just about 6 seconds from now. Now, we won't have the same views as we did on Flight 12 of our payload. We don't have those cameras.
There will
on
be
board
views inside.
these
I'll be
Starship
shocked if there
version
isn't.
3s. That was a Dodger Dog exclusive, but we will be able to see them deploy from the ship.
As Kate said, we should see the door open up really soon if we haven't quite gotten it open already. We've got 20 of these Starlink V3 satellites. Looks like the PEZ door is open. And so, yeah, this is the first time we've got
Man,
Starlink
there's a
V3
hell of a lot
satellites
of
getting ready to go into space.
RCS
these
firing
things
here.
Are really just kind
I
of
don't know,
crazy
Farouk, about
upgrades
the speed.
that they're going to bring to the network.
It is
where
going
you
pretty
start
damn
talking
fast.
About just symmetric gigabit speeds through the Starlink network, pretty much anywhere on the planet that this is going to unlock. So really exciting. These satellites are only going to be in space for about 20 minutes. Sorry about that. These will only be in space for about 20 minutes.
So that's
They're on
another
the
reason
same
why
sort
they
of
need to go orbital,
trajectory as
as
Starship
opposed to
itself.
just throwing 20
This is
operational
essentially just
satellites
giving
out
us a
and then
chance
having
to
them
try
burn
and
up.
run as many tests as possible. Deploy
People, you're
the
right.
solar
This
arrays,
is awesome.
antennas, whatever we
It
can
is
on
really
these
cool to
vehicles.
see all this stuff happening
We
in
are
real time.
intentionally
It
being a
is
little
so
scrappy
awesome.
with it. They might be playing some bumper cars once they're out
For
of
the most
door.
part, things have
But
gone
we
good.
are
I mean,
looking to get these deployed.
it's just there
over the next
there
couple of
appeared to
minutes.
be
In
some
the
engine
meantime,
relight issues
they're getting
and
ready
not a
to,
very soft splashdown
also
for the
do
booster.
Raptor
I
in
don't
space
think that
relight.
landing went the way they
listening to a little bit
wanted
of
it to.
conversation on that, but we are currently tracking to do it. I'll give you some updates if we hear otherwise.
And there you go. You can see our first Starlink V3 getting deployed out of Starship.
All right, satellites being
Huge milestone for the
deployed.
team out here.
Off they
The
go.
crowd is definitely hyped about this. We could see these Starlink V3s continuing to pop out with deployment assisted by the
And
PEZ
yeah, these
dispenser.
are
Now, this version of
real
Starship is
Starlinks that
built
are
to
being
deploy
deployed,
up to
but
60 of
unfortunately
these
they
more
will burn up
advanced
in
Starlink
20
version
minutes
3 satellites.
because this is a
Each
suborbital
V3
flight.
is designed to offer 1 terabit.
I think if we have a smooth landing, I think the stocks are going to go up. I don't think investors are informed enough to know that a not quite perfect landing is, is in any way problematic. As long as this thing does everything it's supposed to do, launches the satellites properly, which it's doing, and then splashes down okay, re-enters and splashes down okay, then yeah.
Off the planet. So thank you.
And
Starlink,
by the
for
way,
letting me watch this
well,
stuff as we fly through space. It's pretty awesome.
Fortunately, these satellites will
about
not be up long
240
enough to
megabits
contribute
per
to the
second
Kessler
of
effect.
data rate
They'll be gone in 20
off
minutes.
Starship, which everybody in the spaceflight community knows that's pretty insane when you're usually dealing with single digits on some of the older systems. So gives you a lot of insight,
folks,
gives you a lot of ability to just rapidly iterate, know what the heck happened when things go wrong. But
Waiting to see the actual views because they have 6 satellites this time with cameras on them instead of 2. So it should be pretty impressive, the view that we're going to get of Starship. Once again, though, this deployment is happening in darkness, in the Earth's shadow. As you can see, it's very difficult. You can't see anything aside from the port being open. The deployment port,
cameras that are going to be
PEZ
looking back at
dispenser
Starship,
thing. So
turn on
that
some
being the
flashlights.
case,
And this is a
I don't know
test
how
of the
good of a view
capability
we'll
that
get
we're really gonna
unless
want,
they have some sort of
when we
low
start
light
doing orbital flights,
infrared
just add that extra
cameras
layer
that'll give
of
us a
safety,
good
that
view
extra
of it.
layer of reliability where we're going to be
So
able
far,
to
these
image
deployments
Starship's
are
heat shield
going very
after it's gone through
smoothly.
ascent, after it's been in space, before it re-enters. So we're
But
gonna try
different
to test
than the
that
way
again
Falcon
today.
9 deploys them, of course.
The
Falcon
heat shield
9
imaging, we
deploys
didn't
them
get
all
a
in
whole lot
one
last time. Oop, looks like we got some thunderstorms
big rack,
on planet
essentially.
Earth below us.
That
But
eventually
couple more
starts
satellites to go,
starts
looks like.
deploying them after Falcon 9
Yeah, it's
deploys
pretty
the
awesome
rack,
to see
whereas
our
this, the rack
V3s
is
in
internal.
space.
Oh,
I
wow.
wanna give
Was
a
there
shout out to our
I think we
Starlink
might have
colleagues.
just noticed a
Now we
lightning
expect
flash
payload
at the
deploy to
bottom
run until
right-hand
about
corner.
27.5 minutes, so about another 7 minutes here. The Starlink team will be attempting to speed run these tests, or excuse me, speed run test these version 3 satellites, where they will attempt to do a few tests such as extend the new solar arrays and antennas. They're also going to try and connect these V3 satellites with ground stations.
Again, deployment of
turn
one
on the
satellite
satellite's
after another. It
communication
all
systems.
looks very smooth. Doesn't seem to be
They're only
any
gonna have
issues here.
about
For the
20
most
minutes or
part,
so to
this is a
do
good
all of
flight.
this, as these
The-
satellites only
As
have
I
that
say,
long before
you know,
they
just
demise
that little
in the
thing with the
atmosphere or
landing.
break up,
I
due to
don't
that
know if the
friction
engine
when
relight
they,
situation was optimal. Didn't look
re-enter the
like it.
atmosphere.
But
So
again,
what we learned from today's deployment will
that's the only
help
thing.
progress,
Everything
and
else,
move the
man, has
program
been so
forward,
good so
which is
far.
super
And we'll
exciting.
see how the reentry goes.
You
But
could
generally, they've
basically
done a
say
damn
that
good job for the
payload's
reentry.
payload is data. Like,
That's right.
we're getting very Inception here.
Reentry
Now, in
should
addition
take
to
place
those
in
tests
about
for
another
Starlink, for the Starlink team,
40
as
minutes.
Dan mentioned, 6
30 to
of
40
the
minutes.
satellites have been modified with engineering cameras to help scan Starship's heat shield. That will help inform
Thank you,
our
G85.
analysis
Really
of Starship's
appreciate
readiness
the
for future
compliment. Thank
catch
you.
returns back here at our launch site. So
Yeah,
for those that
Immortal
might be
Duke, that's a good
unfamiliar,
point.
We are currently
I
capable
mean,
of
it's
catching our
until
super
they
heavy
can
booster.
land that
We've done
booster
a couple times.
reliably
We
and
have not yet
smoothly.
attempted to
Yeah, it's a
catch
single-use
our
booster.
second stage or ship. And
You
so
know,
that
you
is
got
going
to
to be a very exciting
reusability is a
milestone
key
when that day
point
comes.
on all of
For
this.
sure, and we're building
But
up
of
to it
course,
with
they're not going to
today's
get
tests. We are
reusability
still planning
until
to
they
do
actually
our water
do
splashdown
booster
in the
captures
Indian
over
Ocean.
and over and
So
over
stay
again.
tuned for that. That's only about 40 minutes away. But still in space, we keep on deploying our Starlink satellites. Again, these are our V3 version of our Starlink satellites, a whole host of added capabilities to our version 2 that's currently in orbit.
Did we just get a lag?
And this
There.
is our team here at Starbase Texas.
Might have a lag.
These are all of the team members that have helped build the
Maybe
vehicle.
not.
that
Might just
have
be on my
built
side.
The Pez dispenser and got it ready to fly today. Amazing work.
They're still
Now, for those of you
deploying
that have just recently tuned
satellite
in,
after
there
satellite.
is
We
a
should
spaceship
see the
in
camera
your screen, we
views
promise.
at the end.
Right now, the
Again,
ship
though,
is in,
this is very much
orbital darkness, so
dependent
we don't have any
on
available sunlight from the sun to help illuminate the scene. But what you can see moving out from that smally lit space, those are the V3 satellites as they are being deployed. And essentially, the ship is illuminated from the inside, and so we're able to see the light come out through the payload door.
Right.
Thank you,
just
Alpha
a
Sigma.
really
Thank
small
you,
sliver
thank
of
you,
light at
thank
the
you.
top. That's
And
our
well
Pez
said.
dispenser. That's how we're both loading our satellites into the rocket and deploying it. It's pretty novel. We've got about 3.5 minutes still left of our payload deploy sequence.
Yep, looks like we've got 16 satellites deployed, so 4 more to go. These last couple will have those cameras, so if you see any sudden bright lights, that'll be flashlights turning on those satellites to try and get some imagery of Starship's heat shield. 17 out the door. 3 more to go.
Yeah,
and
so they're going to
18.
light Starship up and then try to film it. Interesting. Very interesting.
All right, and while we wait for these
See what this
last
looks
2,
like.
We did confirm we are still
Assuming they're
for
successful
our
here.
Raptor relight demonstration a little bit later in the flight today, so we will be looking to relight one of those Raptor engines on ship.
Okay, so they're going to
That'll be
try
a
to
major
do a
milestone
Raptor
after we get
relight as
through
well.
These final 2 satellites.
This is all very good, guys. So the Raptor relight's going to be key here. Very important.
Just at 25 minutes.
I don't
into
know
our
if they have
flight,
any
it's
plans
crazy
for a
to think that
Starship
we're
space
already
station in
screaming
the
at
near future.
27,000
I
kilometers an
don't
hour,
think
200
that's
kilometers above the ocean
this is a
surface.
transportation system, not a space station
Amazing.
system
Yeah.
thus far.
Now, for those of you that lost count, we have deployed almost all of our 20 Starlink satellites. I believe our last count was at 18, so we should be seeing 2 more. And we're very excited to see our version 3 satellites
John
in
Morgan,
space.
thank you.
And
Thank you
these
so
are
much for the
fully,
5. I
like,
really
these are real
appreciate it.
satellites.
And
They're
yes,
not just demonstration,
you got to get to the
sats like
pub
we had
first.
last
I
time.
understand
These are going to basically have a
understand the
20-minute
philosophy
lifespan
behind
where
that.
our
You got
Starlink engineering
18
team
out of
will
20
attempt
super
to
chats, by
perform
the
a number
way,
of
folks.
tests and really speed
And
run
just so you clear,
tests during
we're
that
giving
time.
away
Right. And in terms of
2
satellite lifespan, 20
custom-made
minutes is the
videos
shortest
to
you can
2
possibly get,
random
but
super
hopefully
chat
in that 20-minute
contributors.
time frame, we can
So
really
I'm
try and
gonna
ink out
give
as
you
many tests
folks,
as we can.
I'll announce
It
who
looks
the
like we
people
might
are at the
have
end of the
some,
stream, and then
This
you
might
get to
actually
choose
be
what
light
kind of
from
video
one
you want me
the
to make.
Starlink satellites, as we mentioned before, a few of them, 6 of them actually are equipped with flashlights to look back at Starship, as we want to image the heat shield and understand the heat shield performance through the ascent phase, as this information is very important for us to know and understand as we
Starships
prepare for operations
desperately
that
needs
will
to have
enable
astronauts
ship
on it by
to come back
2029.
to Starbase for
To
landing.
answer the question
Or
there,
catch, I should say.
Bradley.
Right.
So I don't know. But to answer your question, it is
We
hard to
are
say.
about 40
And
seconds
by the
away
way,
from
these
that
are only
planned
astronauts that are going to be
payload
landing
deployment
on the
sequence being
moon with
complete.
Lunar Starship in its lunar landing phase.
Yep,
To have
looks like we've
astronauts
just
on
got
the ship all
those
the way through
last
the
2 to
flight
go.
process That's probably going to be the 2030s.
These ones might be coming out. They're starting to see
before
motion.
they're at that point. All right. Looks like we have the final satellites being deployed. UKG85, thank you so much for the $5. Payload weight is less than 50 tons. With 20 Starlink satellites on board, it's still not as much as it's not really closing in on what Starship's supposed to be capable of.
Its payload bay door and continue to coast around Earth to the Indian Ocean.
All right, so they're done. They finished deploying the Starlink satellites, all 20 deployed. Very good. You know, of course, they deployed dummy satellites the last time, so they already proved the viability of the system. But now the Starlinks are going to communicate with the rest of the constellation, do some brief tests with the rest of the constellation. But unfortunately, all 20 of these damn things are going to burn up in the next 20 minutes because this is a suborbital flight. Again, that's, you know, that's why they need to go to orbital flights here. And I really hope this happens soon. I really hope it does. Alpha Sigma, thank you so much. Boy, you've been just tossing the super chats out tonight. Thank you. Thank you. Winning in small steps. Oh, there's the illumination. Oh, yeah. Beautiful. Very beautiful. Man. And of course, right now we have more music. I'm not sure when they're going to fire that engine. They're going to have to do it soon. It's not a whole lot more time before they're going to be splashing down. Wow. Yeah, I don't know if they're going to count that as a mishap or not, considering that the mission plans said that they were going to be hovering before it was going to be a soft splashdown with a hover, essentially, almost like a simulated capture maneuver. And that's not what happened. Instead, it just kind of plummeted into the ocean. I'm not sure what they're going to call that. We'll see. All right. Now we have more maneuvering. Wow. You know what? This may not be maneuvering. I think these might be the satellites orbiting the ship. I think that's what we got going on right here. I think these are Starlinks orbiting the ship, perhaps. I don't know. But looks like that to me. Yeah, I think that's what they're doing. I think that the Starlinks with cameras on board have been deployed into a position to where they can maneuver around it, kind of orbit Starship. The coins are to acknowledge, and by the way, I'm not the one hitting the button, but it doesn't matter. I totally support it. The coins are to say thank you, to acknowledge the generosity of people who are doing super chats. Is it the flap cam? Really? Are they're just maneuvering the flaps? I guess so. But they were talking about how they were going to put the satellites in close proximity to the ship. I've never seen this before. I've never seen them move the flaps this much this early in the flight. I don't know. Well, Farouk, they're up less than 200 kilometers, 180, which is only 80 past the Kármán line, and not it. In order for them to be on an orbital trajectory, that means they would have to be on a trajectory that takes them around the Earth at least once, and it's not. So, yeah, it might be the flaps. I don't recall seeing that before, but and also they were making a big deal over the fact that they were putting cameras on the satellites, and they were going to be giving us some views of the heat tiles and that sort of thing. Thank you so much, Bad Raccoon, for the $10, and thank you for your opinion. And I think it's very possible that China will win the race. I think that's very possible. Is Starship a scam? Don't think so yet. There are some very respectable engineers who didn't always work for SpaceX who are involved in this. I'm not convinced that they would do that. Mr. Gillespie, I guess, thank you so much for the $5. Real Starlink V3s, but the booster's still hard flashed. How many suborbital flights? I don't know. I mean, I think honestly they should be doing them now. I mean, just because the booster doesn't fly perfectly doesn't mean that they can't go to orbit. Wow. No, look at that. Those lights are from the satellites. So so it is the flap cams, but the satellites are illuminating Starship for us. That is the plan. Yes, both of them are going to be competing for Shackleton Crater. One of the big reasons why we need to get there first. Although now they're talking about an equatorial landing. Different people at NASA, just because it's easier on the first landing attempt, land at the equator. Thing of it is, if China decides to land at the South Pole and then sets up property rights, they can get the best stuff, especially when it comes to lunar ice. They can take advantage of those resources. Paul, thank you so much. I appreciate it. We hit our goal, by the way. You guys are fantastic. So we're going to keep track of everybody who's done super chats, and then we're going to go ahead and give out 2 prizes, 2 custom videos. Whoever wins, you guys choose what video you want me to make, and I'll make it. SpaceX is going to be on an accelerated launch schedule. At least, yeah, you're right. This is definitely a much better flight than the last one. One would certainly hope so. It all depends on whether or not they call this thing, this hard splashdown, a mishap. Kind of doubt it, but they might. It's really hard to say. Fingers crossed, guys. We need to have another launch soon, another test flight soon, and it needs to be orbital. We got to start graduating to orbital flights, especially since they're talking about all this crap with Starship providing the thrust, docking Orion to Starship and Starship pushing Orion to the moon. I still don't like that idea in the short run. In the long run, sure, but Artemis 4, after SLS successfully gets Orion out to the moon and back twice, now you want to just give that up, just abandon that process, use SLS to just get to orbit, which is the most wasteful thing in history. Using that multi-billion-dollar rocket just to put Orion in orbit. And the only reason they're doing that is because they're congressionally obligated to use SLS. And then they put Orion in orbit, Starship docks with Orion and pushes it to the moon. Why? When SLS can have a Centaur 5 upper stage get the job done in one launch rather than wait and to get it there quickly, as opposed to waiting for a docking with Starship and a whole new process, and also human rating this stack this new stack of Orion plus Starship for that flight, it's just adding a lot more complexity unnecessarily.
That is awesome. Hell yeah. Shout out to our Starlink team. We're so thrilled.
Huge milestone. And that's only 3 minutes or 5 minutes after
total
deploying
success
them. I mean,
on the
Amazing.
satellites. That's
and
great.
right now, we are expecting a relight of a single Raptor engine, and that's going to be coming up in just over a minute and a half from now.
That's right. We
Here
are going
comes
to be
the Raptor relight,
one
guys.
Of our sea level Raptor
This is an important
engines,
one.
and this is
It's not
essentially
tumbling.
just a
What you
demonstration
have
that you
is
can
clouds
relight
passing
an
by
engine
underneath.
after it's already done its ascent
It's
burn.
actually very
And
stable
this is
in its
gonna be
current
really
position.
important when we
And
do
by the way, you can
maneuvers
see
for orbital
the
missions,
attitude of the
whether we're
rocket on your
relighting to go
bottom
into
right.
orbit,
It shows a
or if you're already
depiction
in orbit
of
and you're getting
where
ready to do a
Starship
deorbit
is
burn.
attitude-wise.
We did hear our Raptor team is go for the engine relight, so not going to be skipping it on this one. So we should see that coming up in just about 45 seconds from now. Again, this is
Here we
not
go.
a deorbit burn for this ship. We are on a suborbital trajectory, so this Starship is
Here we
coming
go,
back
guys.
over the Indian Ocean no matter what. But this is going to be a pretty critical test for what we'll eventually need to do when we do orbital missions. When you got to relight those engines, do a burn to get yourself out of orbit. One thing that is unique on this one is we're going to be lighting it for a little bit longer of a time. We're expecting this burn to be up to about 14 seconds. We've only done about 3 seconds previously. And so that should be coming up within the next couple of seconds.
About a 14-second burn. All right. Here we go. This is the real thing here, kinda. Here we go.
You see relight there on your screen.
Looking good.
Wow.
I think.
And confirmation over the net.
Yep.
Relight shutdown.
This is looking
The
good,
burn
guys.
has ended. Congrats to the team on this milestone. I mean, it's crazy to see how we can maneuver in space, and just another icing on the cake.
Successful
for today's
relight,
mission.
guys. That's
So
another
we're gonna be
milestone that
taking
makes
another
this
quick
flight
break.
even
We'll be
more
back
successful.
in a couple of minutes before re-entry, which is targeted for about 2
That's
plus
real
47
good,
minutes.
folks.
So we'll see you
So
soon.
that's, again, pushing this flight closer towards total success. Again, that thing with the booster, that sucks, but really, given all the other milestones that are working here, that's a good thing. Honestly, once again, I just don't see why they can't go orbital on Flight 14. Just because the booster didn't relight properly, you can keep trying to land the booster on orbital flights. There's no reason why they have to keep doing this. But again, we'll see. Let's see how the re-entry goes. That's very critical, obviously. But the engine relight was successful. Obviously, we're going to get some data out of that. But really, near as we can tell, we had a successful relight, which is so critical to do those orbital refueling tests. Great stuff. Yeah, a point was made by one of our team members, and a very good point. That 14-second relight is actually what is necessary to deorbit from an orbital trajectory, to bring Starship back down to had suborbital trajectories that automatically go back in. So what did they accomplish this time that they didn't do the last time? An engine relight and successful deployment of operational Starlink satellites. And plus, the booster did a better job this time. And also, no engine failures on the way up. Didn't have an engine failure on the booster on the way up. There may have been relight problems. It looks like there were, but no problems on the way up, and no engine failures on the upper stage. That is a big jump forward for where we are on the previous flight. No, I definitely think that a booster landing in the Gulf in a ship catch attempt is definitely possible. Yeah. I don't see why they couldn't do that. I'd really like I say, it's Starship needs to get orbital in order to do all of these things. We don't have a lot of time left. I mean, we've got a year and a half maximum for Artemis 3 and then Artemis 4. 2.5 years total. Less than that, actually. Less than 2.5 years in the current schedule. Yeah, I do suffer from hand tremors. Thanks. It's been a long time. And it's been a long time thing, though. I've had that issue for a very long time. Yeah, you're probably right, Havoc. A ship landing in the Gulf would be first. I wish I'd seen that. Oh. What was that? Oh, wow. Yeah, I saw this blue flash. I think that might have been a lightning, a burst of lightning from the clouds below. See, there you go. Another one, another one. Yeah, I think there's a storm underneath Starship. And now we've got re-entry underway. Boy, my God. I think there's God, is there a lightning storm going on below Starship as they're trying to do this? Re-entry underway, folks.
These pretty cool views on your screen. The ship is currently re-entering the Earth's atmosphere. Now, we probably have some first-time viewers tuning in today, so let's talk about this phase.
Right, so re-entry, it's a critical phase of flight, and we need information on how the ship's systems perform. So re-entry, you can see that speed in the bottom left-hand corner of the screen. We have
Carla,
to
that's a very nice
all
thing
of that
to say.
speed
Thank you.
down, so that way we can safely land. It's a lot of energy to be able to scrub down, and it's all the energy that we just used to launch the rocket as well. So Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests, is to see how the ship performs in space and evaluate how it works. Starlink provides us with one more path to collect data to help us rapidly iterate Starship's design.
Yeah, exactly. And if the ship manages to, again, make it all the way through re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere.
Thank you so
and it's doing
much.
So at hypersonic speeds,
New
or
Next.
more than 5
Thank
times
you
the speed of
so
sound.
much for your generosity.
Re-entry is typically a portion of flight where we don't have
Jack Morgan,
communications
thank you.
with
Odds of
spacecraft
Starship
because
having a
it's
soft
re-entering
water
at or
landing
around
and on
orbital
target.
velocity, which
I'd say
is roughly 8
a good
kilometers per
chance.
second, or about
They've been
5
doing a
miles
fine
per
job
second.
with it so far,
So
especially
at those
given the fact that we had all the
spacecraft is moving
engines
through
burning
the atmosphere
properly.
so fast that it creates a
Yeah,
plasma field.
and we'll see
around
on the
vehicle.
relight, but the relight
That
looked real
that
good
blanket of plasma distorts
on
communication
the orbital
frequencies,
relight,
so
so
it's
we will
not
see.
uncommon to experience brief blackouts in communication. Starship is designed
Don't know
to
how many
land
orbits
on
there'll
Mars
be
where
on the
there are
first
no
orbital
runways
flight,
or
at least
other
a
humans
couple,
to
I
help
would
out,
think.
which is exactly why we're testing this landing procedure that we're doing today. And we're doing these propulsive landings instead of more traditional means like parachutes, because
Flaps have
propulsive
taken
landing,
control of the vehicle.
you heard that call out, flaps do have control of the vehicle. You can actually see one view, your screen moving around. That's actually a camera affixed to the flap. So as I was saying, we're testing
This
these.
is looking
doing
very
these
good,
landings
folks.
instead
Very
of more
good.
traditional means, so that way propulsive landing
Yeah,
can
this
enable
is,
more rapid reusability.
for the most
Yeah.
part, a hell
Now,
of a
we did just hear that
flight.
call out. We should continue to hear some call outs as the
Best
ship
I think
makes
I've
its
seen.
way back to Earth. Now, when we hear something called entry max heating, as well as entry max Q, that means that the ship has made it through the maximum heating and aerodynamic loads that it experiences as it returns.
This is
So,
where your heart.
safe to
I'm
say
not
that
sure
it
if
makes it through
that may have
those,
already happened.
specific points, we're doing pretty well.
That's right. So we'll continue to hear multiple call-outs as we go through this phase. One of those call-outs,
BJ Turon,
will
good to
be
see
that
you
the
again, and
ship
thank you
is
so much for your
transonic.
support today.
We'll also
Thank you,
hear
thank
another
you,
one
thank
when
you.
it's subsonic. Transonic will be referring to the period of flight where velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound. So somewhere in the range of Mach 0.8
Man,
to
Professor,
1.2.
yeah, I
For
agree.
reference,
I wish
commercial
that they had
jets
just
have a
tested
range
a
of
few of
cruising
them
speeds, but
instead of
most
20
fly at roughly
to let 'em
Mach
burn up in 20
0.74 to
minutes.
0.85. Just for reference, that's between 480 miles per hour to 575
I hope Starship
miles per
Flight
hour,
14 goes to orbit, but I don't
770
know.
to 930
First flight
kilometers.
from Pad 39A, hard to say. There's a lot of
Subsonic,
complications
another
with
call
that.
out that you'll hear later on in the stream.
Hopefully
Subsonic
soon, they're
will
going to
refer
need
to
it.
speeds that are much
They'll need to
less
be
than
able
the
to
speed of
launch from
sound.
there
So
in order to
at
do
this point in
proper
flight, the ship's velocity will
flight
be
cadences for refueling.
and return just before the ship's landing burn, targeted for T plus 1 hour and 5 minutes.
All right, folks, they are taking a break, and so am I. I will be back in just a second, folks. In the meantime, enjoy this spectacular re-entry. All right, folks, I am back. So far, everything's looking quite optimal. Havoc, I'm not going to discuss specifics about drugs on this live stream. Suffice it to say, I'm not a big fan of it, but I'm sure there definitely are medicinal uses for it. But I'm just not a big fan. Ice, thank you so much. Ice Core, thank you so much. Another $10 super chat. Boy, you guys have been fantastic during the stream. You are so helpful. Thank you, thank you, thank you. Man. I'll tell you. Interesting. Mr. Gillespie, thank you so much for the $5, mate. Really appreciate it. He plans to use Optimus to Starship to replicate human testing in vehicles. It makes sense that they would do that, but to my knowledge, they haven't announced it. They've announced that they are going to be using Optimus for certain Starship missions, but I don't know if there's been specifics mentioned. Yeah, if I'm going to say anything, about Special K, Matthew Perry was killed by it. It's dangerous, and I saw plenty of it when I was an active heroin user, and I never saw anything about it that I liked. So that's my, that's the thing I want to share, I guess, on this stream, is the fact that I am not a fan of it at all. And I don't think anybody should be using it except perhaps in real extreme circumstances. Okay, that's enough of that. Good job, Lee. Well done. Yeah, this re-entry is going very smoothly. This heat shield is holding up very well. And there will be a slight increase in speed and re-entry heat during an actual orbital entry, because there's a difference in speed of a few hundred kilometers per hour. But overall, it's maybe 10%, something like that. So it should be okay. Good for you, NPC. That's a tough thing to get clean from, too, let me tell you. Oh, wow. Carlo, that's a long time to be sober. Congratulations, my man. A long time. Man, those flaps, that shield, all of that is holding up spectacularly well. Yep, I agree. It does look textbook, Alpha. Definitely looks textbook. For the most part, I'd like to say there's just one asterisk so far, but other than that, this flight looks really, really good. And yeah, I think we will see Starship Flight 14 shortly after this, Marina. I think we're seeing things from a slightly different angle, and also it's nighttime where the reentry is taking place. I think that makes a difference too in terms of its appearance. Thank you so much for the 20 quid. Thank you for the Saxavord support. Thank you so much. Yeah, Professor, this is a very advanced generation of the heat shield. The previous heat shield, there's always parts of it that were burning through. It looked real ugly during the re-entry, just really cooked. This one is from the from as near as we can tell from the post-landing, the brief post-landing shots that we get are just during the landing. Looks pretty good. And by the way, as you can see, speed is dropping off tremendously as the altitude is now just over 50 kilometers. And so therefore we got a dense atmosphere. So it's heating things up substantially, but at the same time, speed's dropping off and there's no signs of any problems. This heat shield's holding up well. This is looking really good. Whole flight's looking really good. Like I say, that booster landing was the only potential issue. I mean, if you're doing 15 refueling flights, you don't want to lose 15 boosters. So they're going to have to figure that out. But at the same time, it's looking pretty damn good. Don't know. We're looking at adding about another 12 to 20 tons from the tiles somewhere in that vicinity, which of course makes it a lot heavier, and that impacts payload and everything. So Starship still needs to prove itself in terms of the amount of payload it can actually deploy to orbit. But yeah, this is good. Thanks, NPC, for saying that, because yeah, I just advertised that recently. Aside from the solid rocket boosters, the SRBs, that's the only thing. But if you take the entire SLS full stack dry, that's the same roughly as as Starship's upper stage. Heavy, and that's one reason why it requires all of this power, this massive amount of thrust, in order to get something that heavy to orbit. Farouk, I don't know. I'm not sure exactly. I know that it's used for stress and stuff. Yep. That's it. The heating is pretty much over, guys. It looks like this heat shield has passed the test with flying colors. I see no evidence to suggest that there's any problems there. Yeah, very impressive, folks. This is the best test flight I've seen. And like I say, I mentioned the booster a bunch of times, but really, this is impressive. Christina, thank you so much for your generosity. Thanks so much for your support. Boy, we've had super chats just, and that's your first ever. Thank you. I'm honored that you've decided to do a super chat here on this channel. Thank you so much. I have no idea on the Swift boost rescue mission, Mad Professor. I mean, I did a video about it recently. Not a lot of people watched it, but I did do a video on the topic. And yeah, it's very exciting, really important. So hopefully, once they dock, they're going to do a live stream of the docking of the spacecraft docking with the telescope to push it back up. We're at just over 33 kilometers or so. And again, speed dropping off rapidly. All the heating is done. I mean, it's still going very fast, but really no significant heating. And I'll tell you, that heat shield looks like it's in damn good shape. I don't see any evidence of it being suffering too much. Altitude dropping off rapidly, as is velocity. But yeah, again, we've seen this a number of times before, although I'm not sure if I've ever seen the heat shield do this well. All right. Speed is really dropping off now, guys, rapidly.
On your screen with crisp views from Starlink. The ship is currently re-entering the Earth's atmosphere.
20
over the
kilometers,
Indian
under
Ocean.
20 kilometers at
And
this
really
point.
For the last several minutes,
Just over
we
the
had some
altitude of
amazing
a
technical
commercial
reviews.
jet.
It really looked like
and
it was
plunging
made out of
rapidly
starlight.
towards the
Now, we
ocean.
did hear on the nets just moments ago that we made it through
Pretty soon, it's
max
just going to be
heating
pretty
and
much
max
at terminal
dynamic pressure,
velocity.
meaning that the vehicle temperature and speeds and pressure are all coming down, and we can see that in the bottom left-hand corner of your screen as that speed continues to decelerate. We're coming up to
I don't
the
know.
ship
I mean,
landing
we're going to
burn.
have to check the reusability of
One
these heat shields.
Pretty much everybody's favorite part.
The shuttle's heat shield did a good job. They always lost some tiles here and there. But the heat shield overall did a fine job on the shuttle. We're going to have to check the reusability of this heat shield. How many times can it be used?
Do the flip.
All right, so Starship at less than 10 kilometers. We're seconds away from the landing burn, guys. We're about to go plunging right through the clouds.
Drones in range with the recovery
Thank you so
team.
much,
They're gonna be standing by to
UKG85.
try and
Thank
get
you.
Some additional views.
It depends on the
Starship's heat
launch.
shield, which
I don't know.
kind of
There's
our
some
initial
launches
looks,
I'd be okay
it did
with,
pretty
some that I
well on
wouldn't.
the flight uphill, but we'll continue to dig through all the visual data as we get it. We didn't do any real stress tests or anything on this flight. We did do,
Okay.
you heard our
Very
landing
close,
march
just
flight
about to
controller
plunge through the
call out.
clouds,
We were doing the
guys.
swoosh maneuver, this
Or
kind
the
of the
cloud
final
level,
maneuver that
anyway.
we plan to have starships return.
Moment of truth, folks. It has been so good up to this point. Now we need a good relight and landing burn. If we get this, SpaceX can congratulate themselves on a pretty damn good flight. Not 100% flawless, but a pretty damn good flight. Down through the cloud level. Seconds away. Here we go. Lighting up. Engine relight seems to be working fine.
Did our flip down to 2.
Yes.
Starship descending
yes.
into the Indian Ocean.
Oh.
Down to 1.
Yes. Yes.
And we're in the water. And it's a soft splashdown in the water.
That looks pretty damn good. That looked pretty damn good, guys.
That is a first.
Again, hard to tell
That is
for
the
sure
softest
from that
splashdown
angle,
we have
but that
ever had
looked
with the Starship
pretty
there in
damn
the Indian Ocean.
It's bound to be an exciting
Very
day for our
nice
recovery
indeed.
team. I mean,
And now it's burning, but not
few
blowing up. It
trials
will
don't
blow
even
up
get the
shortly.
soft
But
splashdown,
sure.
much less have the vehicle stay
But
afloat.
that was pretty damned impressive. Again, what an angle they got on that thing. What an intriguing angle they got drone-wise. You know what? I don't think it is going to blow up. I think they burned through all the fuel during that landing attempt. That was pretty damn good. Yep. That's the first time ever that that's happened, guys. First time ever that there's no explosion. Unbelievable. Best landing ever, near as we could tell. The angle, I'm not sure from the way they filmed it, that was a little weird looking, but generally I think that was still good. It was just from the angle that they were filming it that made it look a little odd. But overall, my God, so good. So good. And the fact that it didn't blow up, God, it had to have landed well for that reason. How impressive is that? And they may have like been able to vent off most of the propellant at that point. I mean, there's still a fire burning, and it may blow up eventually, but my God. Wow. 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 That's super impressive. Yeah, look at it. Look at how good that heat shield held up. That looks really nice compared to previous flights. That looks really good compared to previous flights. Man. Okay, yeah, let's go ahead and do the giveaway. Let's go ahead and do the giveaway, folks. All right. Hang on. I'm going to wait. Let's see. Producer, can you just go ahead and send me the winners over Discord? You want to send me the winners over Discord? Let's just randomly select them. In the meantime, wow, that was impressive. Wow, that was impressive. As I say, 9 out of 10. 9 out of 10. I mean, the booster can't get 10 out of 10 because of the booster. But otherwise, wow, wow, wow. Okay, you're going to do the draw live, and how so, producer? How are you going to do it? Can you tell me who it is? Just vocalize it. Oh, never mind. Okay. Oh, we're spinning it. We're doing the spinner. Yay. Okay, so who wins? Who's winner number one? Winner number one. I can't see it. Sorry. Steve Alp. Mr. Steve Alp. So once again, my email's in the, excuse me, in the description. Just tell me what custom video you want made. Has to be space flight or UFO alien, something like that. But what do you want me to make? Number two. Sorry, my vision kind of sucks. I'm just waiting for it to come up on the big screen here. Bad Raccoon. Bad Raccoon is winner number two. Steve Alp, Bad Raccoon. Congratulations, folks. Well done. So please email me with your video ideas, and I will make custom videos for both of you. And it's something that will go out to the entire community. So thanks so much for your support. And once again, quick reminder, folks, if you want me to cover this launch that's taking place in Shetland, and by the way, they're estimating around the 24th of August. I already have my reservations made for the 23rd. If this is something you want me to do, just so you know, we want to support it. There's also a GoFundMe in the description of this video. As I say, it's not an easy thing to do to get all the way up to Shetland, and not a cheap place to stay. They can't put me up at the spaceport this time because there are so many RFA employees, hundreds and hundreds of these people from Germany and other parts of the world, along with Saxavord staff. They just can't put me up. So I had to pay for lodgings. Not an easy thing to do. This is something you want to support. You already did with the super chats today. But in addition, as I say, there's a GoFundMe there. Again, though, you guys have done a lot for me GoFundMe wise lately. So only support me if it's something you can easily do financially. What an incredible flight on the part of Starship today. Overall, very, very good. The only, as I say, the only negative thing, maybe the booster. We got to find out exactly what happened there. But otherwise, man, very impressive indeed. Congratulations to SpaceX. This is what you guys needed. It's very close to perfect anyway. So close to perfect that I feel confident that they will get something perfect on the next flight or two. And orbital is where they need to go next. Starship needs to go to orbit next. Thanks very much for watching. Please don't forget to like and especially subscribe, folks. And until next time, stay angry about space.